3 over 2, negative 3 over 2.
Well, so 1 over u is like u to the minus 1. So f prime of u is minus 1 u to the minus 1 minus 1, just the power rule. So that's minus u to the minus 2, or minus 1 over u squared. Okay. That's what f of u is. And if g of x is x plus 1, what is g prime of x? What's the derivative of x plus 1?
1.
1. Derivative of x is 1. Derivative of 1 is 0. So f prime at g of x, f prime is minus 1 over u squared, g of x squared, times g prime of x times 1. This is minus 1 over x plus 1 squared. Let me go through this again, because this is a simple example compared to other examples, but it's not simple until you understand it. So the chain rule for the derivative of a composite function says, if you have the composite function f of g of x, the derivative with respect to x is the derivative of f computed at g of x times the derivative of g computed at x. So we have the composite function where f of x, f of u is 1 over u. So f prime of u is minus 1 over u squared. And g of x is x plus 1. And g prime of x is 1. So f of g of x, this is 1 over g of x. That's 1 over x plus 1. And f prime of u is minus 1 over u squared. So f prime of g of x is minus 1 over g of x squared. G of x is x plus 1, so this is minus 1 over x plus 1 squared. G prime of x is 1. So the derivative of f composed with g of x, excuse me 1 second. Okay, sorry, let's go. Yeah, so back to the chain rule. The derivative of f of g of x is f prime of u minus 1 over x plus 1 squared, and g prime of x is just 1, so that's the answer. Okay. Any questions about this? I mean, this takes a lot of practice to get used to using the chain rule. So I don't want to underestimate the difficulty, but this is definitely by far the most difficult differentiation formula to master, but it's also the one that you use most often. All right. So here's another example. Suppose u is some function of x, and let's say it's 3x squared minus x plus 1. And y is some function f of u, which is the square root of u. So if g of x is this polynomial, what's the derivative of g? What's the derivative of this polynomial? dg dx.
6x minus 1.
Thank you. 6x minus 1. And if f of u is the square root of u, what is f prime of u? What's the derivative of the square root of u? Can someone tell me?
1/2 u to the power of 1/2.
Not quite. So u, square root of u is u to the 1/2, so it's u to a power. So the derivative is the exponent 1/2 u to the exponent -1, which is 1/2 u to the -1/2. That's 1 over the square root of u, so it's 1 over 2 times the square root of u. So the denominator is 2 times the square root of u. What is the composite function? What is y equals f of g of x? So that's f of the number 3x squared minus x plus 1. And what does f do to a number? It takes the square root. So their function is the square root of 3x squared minus x plus 1. And what is dy dx by the chain rule? It's f prime evaluated at g of x times g prime of x. So f prime of u is 1 over 2 square root of u. So this is 1 over 2 times the square root of g of x times g prime of x, 6x minus 1. So I have in the numerator 6x minus 1, and in the denominator 2 times the square root of g of x, 3x squared minus x plus 1. Okay. So this is the function I want to differentiate that looks very complicated, and the derivative of this, which also looks very complicated, but we can do it now. Are there questions about this problem? I'm just going to I'm going to spend the whole time today just doing examples of the chain rule. Sometimes, or what is typically the case, you have a function like y equals x squared plus 1 cubed, and you want to find the derivative. And this doesn't fit into any of the patterns you used before today, but you want to look at this and say, well, this looks like it could be the chain rule. This looks like y is equal to u cubed with u equal to x squared plus 1. So if I replace u with x squared plus 1, this is what I get. So it's like I have the function u is a certain function of x, namely x squared plus 1. And f prime of x in that case is 2x. And y is some function, sorry, g, my notation. And y is some function of u, which is u cubed. So f prime of u is 3u squared. So by the chain rule, dy dx, that's the derivative of x squared plus 1 cubed. That's the derivative of x squared plus 1 cubed is f of g of x. G of x is x squared plus 1, and then I'm cubing it. So this is f prime evaluated at g of x times g prime of x. F prime of u is 3u squared. So this is 3 g of x squared times g prime of x, which is 2x. So this is equal to 6x. And g of x squared, what was g of x? X squared plus 1 squared. So g of x times x squared plus 1 squared, that's the derivative. So take a look at this for a moment, and you really have to begin to understand how to solve these kinds of problems. There's a significant skill involved, a technique, which you only acquire by working many problems at home. Especially problems where you have the answer, you can check the answer, so you can tell whether or not you've done it correctly. There's one special case where you use the chain rule, which is called the general power rule. Remember, we proved that for exponents n, powers of x, the derivative of x to the n is nx to the n minus 1. So this is not the general power rule. This is just the usual power rule where y is equal to x to the n. And the general power rule is where you have a function u of x, and you take u of x and you raise it to the power n. And we want to know what's the derivative of not just x to the n, but any function u raised to the power n. And the answer is, this is n, u of x to the n minus 1, looks almost like that, but then times the derivative of u. So that is the general power rule. So for example, if you wanted to differentiate sine of x to the 8th power, that's 8 times sine of x to the 7th power times the derivative of the sine, which is the cosine. Here, u of x is equal to sine x, and n is equal to 8. Or if you wanted to differentiate x squared plus 1 to the 100th power, so this is like u of x is x squared plus 1, and the power is 100. This is 100, x squared plus 1 to the 100 minus 1, which is 99, times the derivative of x squared plus 1, which is 2x. So you get 200x, x squared plus 1 to the 99. And the proof of the general power rule, it's, suppose you have the function y, f of u is u to the n, and u is some function u of x. So g of x is u of x. So the composite function, so this is like my g of x. G of x is u of x. F of g of x is f of u of x is u of x to the power n. And dy dx, it's f prime of u of x, u prime of x. If f of u is u to the n, f prime is n u to the n minus 1, and we're at g to, this is u of x, times u prime of x. That's the proof of the power rule as a consequence of the general chain rule. Suppose we have the function y equals the sine of x squared, and we want dy dx. So we can think of this as, this is the sine of u, where u is x squared. So we have a function y, there's a function of u is sine of u, and u, which is some function of x, is x squared. So f prime of u is cosine u, because the derivative of the sine is the cosine. And g prime of x, that's just the derivative of x squared, that's 2x. So dy dx is f prime of g of x, g prime of x, that's f prime of, what is g of x? X squared. G prime of x is 2x. What is f prime? Sine of u. So f prime of x squared is the sine, is cosine. This is the cosine of x squared times 2x. So for the function y equals the sine of x squared, the derivative is 2x times the cosine of x squared. Well, we've differentiated e to the x. We know the derivative of e to the x is e to the x. But what about the log of x? We haven't worked that out yet. And we can work that out using the chain rule. So this is a very important fact. It should be a theorem, but I'm not sure that it is. The derivative of the log of x is 1 over x. Of course, you know this is only defined for x positive. Of course, the logarithm is only defined for positive numbers. So the derivative of the log of x is 1 over x. So let me see if I can do this using the chain rule, because what we know is we know that e to the log of x is x. The exponential and the logarithm are inverses of each other. So suppose we let g of x equal log x. That's going to be some number u, and y is some function of u, is going to be e to the u. So x is equal to f of g of x. So if we differentiate both sides of this equation, of course, on the left side, it's easy. The derivative of x with respect to x is just 1. And on the right side, we use the chain rule. This is f prime evaluated at g of x times g prime of x. If f of u is e to the u, f prime of u is also e to the u. So this is e to the g of x, g prime of x. G of x is equal to log x. This is e to the log x times g prime of x, which is x g prime of x. G prime of x is what we want to find, and just divide by x. G prime of x is 1 over x. G is the natural log of x. G prime is 1 over x. Again, you're never going to be asked to prove something like this, but the result you absolutely positively must know. Let's do some more examples. Suppose y is the natural log of x squared plus 1. And we want to find dy dx. So we have to do, it's like dissection. We have to decompose this, break it up into pieces. It's like y is a function log of u, where u is the function x squared plus 1. So it's like f of u is log u, and g of x is x squared plus 1. So we know that f prime of u is 1 over u, and g prime of x is 2x. So dy dx by the chain rule, this is f prime evaluated at g of x times g prime of x. F prime of u is 1 over u. This is 1 over g of x times g prime of x, which is 2x. G of x is x squared plus 1. So we get 2x over x squared plus 1. And that's the answer. Suppose we have the function f of x equal x log x minus x. What is f prime of x? Well, for this, actually, you don't need the chain rule, because you don't have a composite function, you have a product and something else. So for this, you only need the product rule. The derivative of x is 1 times log x, minus x times the derivative of log x, which is 1 over x, minus the derivative of x, which is 1, plus. So this is log x plus 1 minus 1. That's just log x. So for this function, when you differentiate it, you get log x. Okay. All right, I just got to keep doing examples. Suppose we want to find the derivative of the log of x cubed. So if you have the function y equals log x cubed, that's like u cubed, where u is equal to log x. So by the chain rule, this is going to be the derivative of 3u of u cubed, which is 3u squared, times the derivative of log x, which is 1 over x. So this is u is log x, 3 log x squared divided by x. Now, take a minute or two to look at these, because this is a complicated skill to acquire, and you need to make sure you can figure out what's going on. I'm picking examples that are in the book, because the best thing to do before and after a lecture is to study the book. And you can see all of these examples very clearly written and legible. Here's a homework problem for next week. This is number 9 at the end of the section. Y is equal to 4x minus 1 cubed. Find dy dx. So work it out and tell me what you get. Right? I mean, the way to look at this is a composite function. It's like u cubed, where u is 4x minus 1. So if you want to write this as y equals a function of u, f of u, and u is a g of x, y, which is this function of u, is u cubed, and u, which is a function g of x, is 4x minus 1. So write down f prime of u and g prime of x, and dy dx is going to be f prime evaluated at g of x, g prime of x. So you need to fill in this, this, and this. So if f of u is u cubed, what is f prime of u? Can someone tell me? What's the derivative of u cubed with respect to u?
3u squared.
Thank you. If g of x is 4x minus 1, what's g prime of x?
4.
4, exactly. So f prime of g of x, that's 3 g of x squared times 4. 3 times 4 is still 12. G of x is 4x minus 1. So it's 12 times 4x minus 1 squared. Are there any questions about this? Here's number 15 on the homework. f of t is the square root of 5 minus t. Find the derivative, f prime of t. So here the variable is t instead of x, but that shouldn't make any difference. Because we can think of y is some function of u, which is the square root of u, and u is some function of t, which is 5 minus t. So f of g of t is f of 5 minus t is the square root of 5 minus t. That's what this is. Maybe I'll call this h so it doesn't get confused with this. So f of t is this function h. H of u is the square root of u, and u is g prime of t. So with this choice of letters, the derivative of f of t is the derivative of h of g of t. That's h prime of g of t, g prime of t. Now, h of u equal the square root of u. We already did this. H prime of u is 1 over 2 times the square root of u. And if g of t is 5 minus t, g prime of t is minus 1. So what we get here is h prime, 1 over 2 times the square root of u, times g prime of t, which is minus 1. So I get minus 1 over 2 times the square root of, what is u? 5 minus t. Let's look at another interesting example. Everything I'm doing is in the book, either in the text or homework problems. Suppose y is the function 2 to the x. We know the derivative of e to the x is e to the x, but what is the derivative of 2 to the x? So you can do this using the chain rule because 2 is e to the power log 2, right? The exponential and the logarithm are inverses of each other. So 2 to the x is e to the log 2 to the x, which is e to the constant line log 2 times x. So this is a composite function. This is like f of g of x, where y is f of u, is e to the u, and u, which is a function of x, is log 2 times the number x. So f prime of u is e to the u, and g prime of x, this is a constant times x, so the derivative is just the constant. So the derivative of 2 to the x is the derivative of f of g of x. That's f prime of g of x, g prime of x by the chain rule. F prime of g of x, what is g of x? G of x is log 2 times x. So this is f prime of the constant log 2 times x times g prime of x, which is log 2. F prime of u is e to the u. So f prime of log 2 times x, this is e to the log 2 times x times log 2. E to the log 2 times x we saw was 2 to the x times this constant log 2. So what we've proved is that by the chain rule, the derivative of 2 to the x is log 2, that number, times 2 to the x. And by the same argument, for all positive numbers a, the derivative of a to the power x is log a times a to the x. So this is the rule for differentiating an arbitrary power of x. Right? Are there any questions about this so far? So we proved that the derivative of the log of x is 1 over x. Suppose we have the function log of u, where u is a function of x. And we want the derivative of log u. So the following is true. This is u prime over u. Okay? The derivative of log u is 1 over u times the derivative of u. And the proof is as follows. Suppose, see, y is what function of u? It's log u. And u is some function of x, which is just this function I'm calling, which is u of x. It's u. So log u is exactly f of g of x in our standard notation. So the derivative of this by the chain rule is f prime of g of x, g prime of x. F of u is log u. The derivative with respect to u is 1 over u. G of x is u of x, so the derivative of g is u prime of x. U prime over u. So that's the proof. So if we wanted to differentiate the log of x squared plus 1, that's equal to, so my u is x squared plus 1. I get 1 over x squared plus 1 times du dx, which is 2x. That's what it is. If I wanted to differentiate the log of the sine of x, where sine of x is positive, this would be 1 over sine x times the derivative of the sine, which is cosine x. So that's cotangent x. So the derivative of the log of the sine of x is the cotangent of x. Now, the logarithm is a very important function. And this is the graph of y equals log x for x greater than 0. It's not defined for x less than 0. But I could look at a different function, y equals the log of the absolute value of x. So now this function is defined for all x different from 0. because if x is negative, absolute value is positive. So this is defined for all x different from 0. And the graph looks like this. It's symmetric around the y-axis. And we can think of this as a composite function. This is like the log of the function u of x, where u of x is the square root of x. What's the square root of x looks like? This is a v-shaped function. This is, let's say the function u equals this function of x, which is the absolute value of x. What is du dx? Well, it depends on whether x is positive, negative, or 0. If x is positive, u is equal to x. So du dx is 1. Because there u is equal to x. If x is negative, this is the line minus x. And the derivative is minus 1. And it's undefined, or it doesn't exist. That's 0. But for non-zero values, the derivative is either plus 1 or minus 1, depending on whether u is positive or negative. So for y equals the log of the absolute value of x, y is some function of u, which is log u. U is a function g of x, which is the absolute value of x. So dy dx is f prime of g of x, g prime of x. That's the log, sorry, f prime is u is 1 over u. So that's 1 over g of x, g prime of x. If x is positive, g prime of x, which is the derivative, is 1. And g of x is the absolute value of x, is x. If x is negative, g prime of x is minus 1. The absolute value of a negative number is minus the number. So it's also 1 over x. So what we've proved is that the derivative of the log of the absolute value of x is 1 over x for all x non-zero. I'll do a few more problems and then we're going to stop because this is the last topic before the hour, before the exam. I remind you, the first exam is a week from today. It's next Wednesday, and it covers everything from the beginning of the semester, section lessons 1 to 11. I will send out a review sheet of a sort, but the best review is just to go over as many homework problems as you can. That's really what's going on. Everything is in the homework. So a few more examples. Suppose f of x is the log of the square root of x plus 1. So there's no reason not to take advantage of the properties of the logarithm. Square root of x plus 1 is x plus 1 to the 1/2. And you can take an exponent out of the log. This is 1/2 times the log of x plus 1. So when you differentiate by the chain rule, there's the constant 1/2. This is the derivative of the log of x plus 1 with respect to x plus 1, which is 1 over x plus 1, times the derivative of x plus 1, which is 1. So you get 1 over 2 x plus 1 is the answer. Any questions? Here's our last example. F of x is the log of the expression x times x squared plus 1 squared divided by the square root of 2x cubed minus 1. So that looks really difficult. And it is, unless you simplify the problem before you even begin to differentiate by using properties of the logarithm. So the log of a quotient is the difference of the logs. So this is the log of x times x squared plus 1 squared minus the log of the square root of 2x cubed minus 1. And a log of a product is the sum of the logs. So this is log x plus the log of x squared plus 1 squared minus the log of 2x cubed minus 1, the square root, which is that to power 1/2. And then we take the powers and we put them in front. This is 2 log times log of x squared plus 1 minus 1/2 times the log of 2x cubed minus 1. So using properties of the logarithm, we can break this up into more terms, but simpler terms. And we can differentiate term by term. So f prime of x, the derivative of log x is 1 over x. The derivative of 2 times the log of x squared plus 1 is 2. The derivative of x squared, log of x squared plus 1, if this is u, log u over u is 1 over x squared plus 1, times the derivative of x squared plus 1, which is 2x, minus 1/2, the derivative of the log of 2x cubed minus 1 is 1 over 2x cubed minus 1, times the derivative of 2x cubed minus 1, which is 2 times 3x squared. So we get as our answer 1 over x plus 4x over x squared plus 1 minus, see, this 2 cancels that 2, so minus 3x squared over 2x cubed minus 1. Okay. Okay, well, this is the chain rule. And I urge you to spend as much time as you can in the next week before the exam practicing how to differentiate functions, especially using the chain rule, because that puts everything together. And concentrate, if you can, on the homework problems on the chain rule, because if you can do them, you'll do very well on the exam. So again, I remind you, the schedule is Monday is the review class, and I will send a review sheet, but you're responsible not just for the problems on the review sheet, but for everything in the course. The exam is Wednesday. At 1 o'clock, I will email you and post on Blackboard the exam, and you will have until 3 o'clock to finish the exam, convert your handwritten pages to a PDF file, and upload the PDF file to Blackboard. You do not email me your exam or anything of that sort. It has to be posted to Blackboard in the exam 1 section. Exactly what you do with your homework. Are there any questions? So, okay. If anyone has questions that come up in the next day or two, if you email me, I will set up an extra help session, maybe on Friday afternoon of this week, but only in response to, requests. So if no one's interested, then I won't do it. Okay. Any questions about anything? If not, then we are done for today.